Alright, what's up, dudes? What's today? Tuesday the 8th. Um, I did code some last night. I'm on leave from my job temporarily until my back gets better. I got another x-ray, some more x-rays done today. And you didn't see anything on the x-rays, but you know, that just shows your bones. So like, you know, I have another appointment scheduled tomorrow with a different doctor that could get me different kind of imaging or like a steroid shot and stuff. I've had those before. Anyway, so let's power in. So we're going to continue where we left off yesterday. Yesterday I had begun the implementation of the conversion from a 4 counter system to a 2 counter system after we did like 2 hours of brainstorming yesterday, which took a really long time. So to make sure that a mistake, because I remember believing that I needed others and wanted to that was wrong when I thought that, and from everything I could deduce I was wrong, and I don't actually need 4, I only need 2. And as a matter of fact, 4 causes bugs, fixes them. I need to, and it's easier, it's simpler, etc, etc. Alright, go ahead and pick up off exactly where that was. I have to see. This real quick. Seeing what time it is in China. In China, it's 12 hours. It's 5 a.m. in China. Alright, there we go. Now, we left off where exactly? Line 130 in change attribute list. So let's go there. After we write this, continued implementation. Continued implementation of version 2 counter system. Alright. Let's go to change attribute list. We're gonna pick where we have it. Search to C1, then do C1 to C2, etc. Where we were at, a project search for C1 to C1. So let's do that. We don't want it to be case sensitive. So let me just review real quick these changes that we made yesterday. So we previously had 1 to 1, 1 to 2, 2 to 1, 2 to 2. We now just have 1 to 2. Right. And then we went ahead and we changed this section in the data transfer function, wherein we are grabbing the cal object integer, which is like whether it's 1 or 2. If it's 1, then we increment the C1 apply counter, because that's the associated client, and then we check to see if the adder name is not in the transferred game adder. In that case, we know we're going to also send it to C2, so we increment that one as well. Same thing, but just choose on the other foot, where it's 2. In that case, we increment 2 no matter what, check if it's a game adder, and if it's not, then we will increment the C1 apply counter as well, because that means it's going to be sent to C1. And that replaces this section right here that's commented out. So here's our so this instance is for client side, and this one's real simple. So this is just going to be C1 apply counter, and this one is going to be C2. Very simple. Alright, so moving on to the next one. So we have the cal tube, and we're not going to have 4 of these counters anymore. We're just going to have the C1 apply counter and the C2 apply counter. Alright, so that means we're going to have to change the associated logic that checks implies we need to modify logic which checked the apply counters, the counters from the change attribute list to elements. Yep, definitely need to do that, because that's not gonna show up in this namespace search. It's gonna be a completely separate. Okay, so we have counter, C2 apply counter, da 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 da. Alright, so that should be good. Alright, next instance is right here. This is just going to be changed to C1 apply here. And we'll copy that and change this to just be C2. And get rid of these last ones. Alright. Next instance. So all this is going to be... hold on. So where did I just make that change at? Wasn't here. Okay, right here. Alright, so we're gonna have to change the comment, but that means we also have to change this right here. So we have the tube 0, 1, 2, 3, 4, 5, 6, 7. But now this is going to be changed to, so timestamp, dir string, then adder name, then data, then C1, and then this is going to be C2. So these last two right here, tube 6, tube 7, are gone. Alright. So now we just have timestamp, dir string, adder name, data, C1, and then C2, and that's it. Alright, so let's change this one to say C1 apply counter, copy it, go over here, and then change this to C2. Get rid of that, the last two that we don't use anymore. Right, that needs to be changed up here as well. C1 apply counter, copy it, the 1 to the 2, get rid of that. Alright, so yes, we have 0, 1, 2, 3, 4, 5, and this matches here, 0, 1, 2, 3, 4, 5. And then we add the send ID, current receive time, sender ID. Okay, cool. So that's, why is this? Whatever, I guess we need it in 2 places, I don't know. Damn. Here goes my back. Alright. Yeah, there we go. So we have 0, 1, 2, 3, 4, 5. And then 1, 2, and 3. 1, 2, and 3. Cool. Alright, next one. It's right here. This is in client what? And let's check our extensions. Okay, yeah, we have to restart this extension. So we are. Which function is this? This is the while loop. This is a main while loop. This is not inside of a function. Gotcha. Okay. So we are checking the sender ID. We then would use C1 to C1. Okay, so all this has to be changed. This whole section basically. 2 billion nanoseconds is equal to 2 seconds. Okay. Sender ID. So this section handles the assignment of, or we increment the C11 expect counter here. Okay. 1 apply counter. If 2 cores are equal to C11 expect counter. Okay, I see what's going on. Right, this is what applies the data to the apply list. This is checking the apply counter of the transferred tuple element against the expect counter. So we're gonna copy this whole section right here. It took me a little bit to figure that out. Alright, now let's get the right indentation level, make sure the indent is right. So you have if apply current, elif if apply current, elif if apply current, elif if apply current, and then that else is a different section. So here's what we'll do. We're going to div that out, 2, 3, 4, 5, 6. Now we're going to comment this out, and now this is going to copy this. 10, 8, 24. Replacing below section, replacing with above section, leaving until 100% sure above is valid. Alright, so now we have the new section. Okay, so it messed up the indentation. We're gonna div this off as well, so we know exactly like what we, these two sections are 1-to-1 as far as what they contain, and that div signifies that. Alright, so now we're gonna modify it. So if the sender ID is equal to 1, and this is on client, and this is main while loop. So we can just say if sender ID is equal to 1, and current client ID is equal to 1, well, that actually doesn't matter, does it? It doesn't. The sender ID doesn't matter anymore. The expect counter is going to get incremented either way. Like it's gonna use the same expect counter. So if we receiving from client 1 and our current client is 1, we're gonna increment the C1 expect counter. If the sender ID is 2 and the current client ID is 1, we're still gonna use the C1 expect counter. If the sender ID is 1 and the current client is 2, we're going to use the C2 expect counter because that's the client's associated ID. And same thing, if sender ID is equal to 2, and client ID is 2, we're going to use the C2 expect counter. So we actually don't need to know the sender ID. It doesn't matter whether it comes from client 1 or client 2. It doesn't determine which counter we use. Okay, so now this can be unindented. Why does that still? I did something. Should be at the... Oh, I hit tab instead of... equal with the W, so it's 2 indents from the below section comment, and then it was 1 indent. So yeah, I accidentally indented it instead of unindenting it. I don't know how I did that. There we go. So now this sender ID doesn't matter, get rid of it, and this can be current client ID is equal to 1. We would just use the C1 apply counter, and that would be, in this case, so the C1 to C1 was tube 4, so it should still be tube 4, I think. Yeah, but we need to verify correct tube index after change from 4 counter to 2 counter. System. Yeah. We need to do the same thing here. I think it would be the same one, but I'm not positive. Now this would just be the C1 expect counter. This would be the C2 expect counter. Now this also should just be C1 expect counter. Same thing here, this should be C2. And now this can go away. We don't use that at all anymore. Alright, so let's verify this. So now we just check the current client ID. We're iterating through the received cal tuplist, which is sorted. Yeah, this is after it's been sorted based on the counter val. Or, I don't know, is this after it's been sorted or before? Let me see something real quick. Where do we sort this data? Okay, right here. So we sort it by timestamp first. Sorts via timestamp since server side. Receive can't just use the counter. But isn't this client side? I'm confused. Oh, so this is code that was duplicated. It's used in both server and client. But if this is only executed on the client side, then what line is that? It's 567. Let me write that here. Let's go back over here and let's make sure this is the main while loop on the client side. Okay, which it is. So we have while true. We assign this actually is filtering the sent received dictionary. Then we start the receive section. We don't really need to worry about these notes. That's for the save system. Then we have ready. Then we check to see if anything has been received by ready. And then we assign various data. Okay, then we check to see if the received data is a list. Alright. And then we end up performing a bunch of operations on it. So if we receive a change attribute list, we assign receive time, receive change attribute list. We create a log, we assign this. We then remove fulfilled resend requests. Checks the associated send data store to see if the received send ID matches any resend request. Okay. Then we have receive verification send ID dictionary. This is for receive verification send ID. C2 to C2 send ID. Okay. Then that's receive verification sending. Now this is incrementing a send ID. This is not the counter, it's separate. Pretty sure we'll keep that. To and receive change attribute list, okay. We append to the received cal2 list, and then we sort it, but it only gets sorted based on the timestamp. But wouldn't it already be sorted by timestamp? I'm pretty sure it would already be sorted. Like, that makes sense to me. Because whenever we add it on the sending side, it gets sent every time. I mean, it gets added every time we make the change, so wouldn't it naturally be sorted by timestamp? I'm pretty sure it would be. Yeah, because all the data point changes are made in chronological order. like that's done through the main thread. So all data changes on the server side are done through the main thread. The client threads just handle receiving and sending data. They don't actually modify the data, at least not in a way that ends up in it being transferred over the network. So, long story short, every time we change anything on server, it gets appended to the changed attribute list in the order that it happens. So that should imply the received cal tuple list is always gonna be organized based on the timestamp, or even if the timestamps are equal, having happened so close to each other, they still should be in the proper order, so that the first one would happen first if you started at the beginning and went to the end. That makes sense, yeah. Okay. But what about and then we end up sorting it immediately after. So like it's already sorted by timestamp, and then we sort it by timestamp. But what we really should, well, this would also be sorted by counter. It would already be perfectly sorted because the as the this should already be sorted. Even by the counter, it should be completely sorted, both in timestamp and in counter val, because the main thread is the only one that makes these changes. The main thread is the only thing that appends to that associated change attribute list. So that means it should have the proper timestamp in order and the counter in order as well. I don't know why I never realized that before, because that should have also been like the case. So I guess that was another instance of just me being dumb before, maybe. Hopefully it doesn't mean that I'm being dumb now and not remembering something. But I'm quite certain the change attribute list gets sent in terms of client to client. There is no intermingling, so all these data changes are going to come from one client or the other. If they're coming from client 1, they're all going to be client 1 changes. If they're coming from client 2, they're going to be client 2 changes. Now, does that sent change attribute list include all the data changes? No, because client 1 handles all shared object data changes, and it handles anything that pertains to client 1. Client 2 thread handles all things that are not shared and are client 2. So this received change attribute list right here, let's look for that, where we assign it. is equal to the core data. So at this point in time, core data is equal to, where is core? Okay, so core data is the actual received data from it's the element of the sent data that is the actual core data. Is it not? Let me see. Okay, yeah, here we go. So we have index 0, index 1, index 2. And we're looking for index 2. Index 2 is going to be the change attribute list. Yeah, the change attribute list. So 0, 1, 2. So let's... So that's correct. Our assessment is right here. I'm going to make a phone call in a second. Before I lose my train of thought, I don't want to distracted. So we have the current client change attribute list. It is equal to the core data. Okay. So yeah, it should be sorted. So I'm pretty confident in this. After reviewing this section, quite certain this data would already be sorted based on both timestamp and counter val. I think so. Pretty positive on this. And say implies that we don't need to sort this again. The only thing that needs sorting is the what's you call it? Is the list. I can't remember the name of it. It's the list which contains all of the data from both clients. Yeah, so this would be sorted relative to client 1 if it all came from client 1, and it would be sorted relative to client 2 if it was from client 2. But if it was from client that doesn't necessarily mean it's completely sorted, right? So I am gonna comment this line out. Actually, I will leave this and we'll put comment this line out whenever we run a test. Whenever we run a test, disable it after the initial test to ensure no change in behavior, as assessment shows there should be no difference. Okay. yeah, so we can move on. So we'll just leave that as it is for now. Alright, so let's go back down here. I kind of forgot where I was exactly. If del elif requested data if link current client received is greater than 0. Alright, yeah, so then in then we check to see, this is application. Okay, now we check to see if the received cal tube list. Oh, wait a second. Oh, no, 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 no. This actually is right. I'm tripping. The received cal tube list is the list. I think. Yeah, the received cal tube list is the list that I'm dumb. Yeah, I'm dumb. We have the actual where is it? Yeah, we have the received cal tube list, and this is the list which contains all the data, I think. To hold all the received change attribute list tuples from both clients, right. Okay, so I'm an idiot. This is that sorting. But it needs to be sorted not only based on timestamp, it needs to be sorted by counter, because the counter is really what's important. I have to use the restroom. I'll be right back. Okay. I'm back. Yeah, we're just gonna do this last 30 minutes and be done for the day. So I'm actually like tired. I donated plasma and it took my energy away. Okay, so where are we at here?
For we don't truly die.
Oh yeah. I know all about it. So I'm pretty sure what actually needs to happen here for this to be proper is for us to sort based off of the counter. I mean, we can do both. We can sort by timestamp. Am I right here? Whenever I make changes to stuff, I need to really make sure, is the change valid? Yeah, I'm pretty certain. We would only change, I mean, the, okay, no, hold on, let's illustrate this. So we have, okay, so let's say this is client side, okay. We are on client 1, so let's just say C1, right? So we receive data from client 1, and we also receive data from client 2. When we receive the data from client 1, it's gonna go into the, what did we call it? Let's see, received cal tuplus. So we'll just put R C T and then L. Alright, so it goes into this, and let's say there was 4 data point changes. So we have, to illustrate this a little more clearly, actually I need to do this a little different. So we do have to show the server side. I didn't think we need to. So we have client side, server side, then we have client 1, C1, and we have C2. Alright, so whenever the data point change is made on the main thread, let's say it's all, and we're gonna label these by number. So we have a data point change, number 1 happens, ends up going to C1 for whatever reason. Either it's a shared object or it's related to number 1 instead of 2. So we'll just make a little box here. This will contain the data point changes. So we have 1, but then let's say the second data point change affects player 2. So then this one's going to have 2 in it, the second data point change, and then let's say the third one affects client 2. Well, I just confused myself a little bit because whenever we transfer to client 1 on this side, because we're really only worried about one client. So this is only for C1. Whenever we make a data point change that would let's assuming that all these are changes that do get transferred to C1 as well, because if it's a game add or change for C2, it's not gonna get sent to C1. So we'll just say the second and third one would have been, but then the fourth data change is a game add or change for client 2. So this one we put an X over it. It doesn't get sent. Alright? Let's pick a different color for the X. Let's pick just this light blue. Alright? But then data change number 5 goes up here, and then 6, and then 7. Alright, so all these are separate data point changes. So we have 2, 3, 4, and we'll just say there's another one, and it's going to be data change number 8. Okay. Now, this is going to get transferred to C1 through the C2 thread, and this one's going to get transferred to C1 through the C1 thread. Now, whenever the C1 receives this data in its well, it only receives one of these at a time. So let's say it receives from C1 first, and that is going to make it such that the changed, what is it called, received cal tuplus, we'll say R C T L, okay, gets populated with the data points changes 1, 5, 6, and 7, and the apply counters associated with them would be, actually I need to make this a little shaped differently. I see how I need to shape this. We'll shape it like this. It's better. So R C T L. Alright, so since it processes C1 first, it's going to have the first data change listed first. Then it's going to have number 5. Then it's going to have number 6. And then it's going to have number 7. And then when C2 gets received after, it's also going to go to the received cal tuplus, but it's going to get added after all those that were associated with C1. But each number designates the actual order of the events. So let's use the green to circle. So we had 1 happen first, 2 happened second, 3 happened third, 4th happened fourth, which didn't even get sent to client 1, 5th, 6th, 7th, 8th. So you can see the order is not perfect relative to how it gets received on the client side. So whenever we receive this, this is how it's going to end up. We then have to take this data, which is not sorted based on order, and we then have to sort it. So we'll just say sort but we have to sort it based on what? Well, it's already gonna be relative to each section ordered correctly based on timestamp. But because number 1, according to the timestamp, happened first, but then number 2 happened second, but it's not second. 5 is second. 2 is way back here. So we have to sort it such that the timestamp so I'm trying to think. We have to sort it by timestamp, and we also have to sort it by counter, because even though let's just say we sort it by timestamp, if we sort it by timestamp, the order would be 1, 2, 3, and then we have 5, 6, 7, and then 8. Yeah, 1, 2, 3, 5, 6, 7, 8. Alright, and this is gonna be, we'll put timestamp sort, and we'll just put TS for timestamp. Okay. Now we have to sort it again. And why do we have to sort it again? Well, let's say that the timestamp for one of these was identical with another, because remember we said some of them, if we can execute like 5 lines and have the same exact timestamp, like the timestamp would be equivalent with the next 3 timestamp values for, so let's say and this would just put CO for counter. Just sort by timestamp, and we have to sort by counter, because let's say 1, 2, 3, and 4 happen so fast that the timestamp value T is equal to 1, 3, 5, 6, 7, 0, 0, 8. That's how fast it happens. These, all 4 of these would have the same number. So when we sorted it, the sort would actually have it as, instead of being ordered perfectly 1, 2, 3, 4, 5, 6, 7, 8, it wouldn't happen like that. Let me get rid of this. Well, we can leave that. It's fine. It would actually be ordered like this. It would be, and I'll just use black. I'm tired of switching colors. We'll just say it would be, well, just for whatever. It would be sorted like this: 1, and then it would be sorted 2. Okay, so we're good so far. Then 3, and then 5. So this actually would still sort it correctly. But I'm trying to, I didn't make it in such a way that it wouldn't be sorted correctly. But like, it could happen. it could technically put 3 before 2. Now, I don't think it would, because if two values are the same, I would think sort would just place them like in order of their occurrence in the list. Meaning if numbers 1, 2, 3, and 4 all had the same value and we tried to sort it based on that value, as long as 1 was first and then 2, then 3, then 4 in the list, it would keep the sort the same. Let me ask if this is true though. So let's say Python Python.sort method. Would it sort 4 variables with the same val, i.e. A equals 1 0 3 2 3 4, B equals 1 0 2 3 4, C equals 1 0 2 3 4, and then D equals 1 0 2 3 4 in the order that it iterated through them, i.e. the result would be A, B, C, D, or would it arbitrarily decide which of the vars were placed first in the case these vals are exactly the same? But the sort method or the sorted is stable, meaning that it maintains the relative order of records that have equal keys. So you have multiple variables with the same value, they will be sorted in the order they were iterated through. So if you have 1 0 2 3 4 da 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 da, the output would be in the original order of A, B, C, D would maintain the sorted order. If you were to sort them in a way that considers their identifiers, that behavior might differ, but with just their values, it would be stable. And let me ask the same question to Gemini, because I noticed that ChatGPT has been wrong a few times lately, and Gemini has been correct where ChatGPT has been wrong. They would remain the same order before sorting. Here's an example to illustrate this. Do you see what they would in order? Okay. Yeah, so it says that they maintain the order of iteration. So I'm going to trust that that's true. So if that is the case, then sorting by timestamp would actually be sufficient all by itself. Is that true though? Because no, that can't. That's not right. That's not right. I know how I can figure. I can show that this is not right. If I were to change, and there's no really easy way to do this, I'll just say it. I'm not going to change it on the paint. If there was a way, like if we made change number 1 here. Actually, I can. I'll erase this. I'm pretty sure this can happen. I want to check this though to visualize it, but I'm almost certain this would happen. Get rid of this. We'll get rid of this order right here. We're gonna completely redo this. now we have let's just say we have 1, then we have 2, then 3, then 4. But let's say, and then we have 5. But if the timestamps for all these are exactly the same, when we receive it, we'll get 135 first. And then we have, when we receive from client 2, it will be 135. Oh, I need to write it up here. It would be 135, 2, and then 4. So yeah, if all of these had the same exact timestamp, or let's just say 1, 2, and 3 had the same timestamp value, it would sort it like this. It would have 1, then 3, because that one's next in the list, right? Then it would have 2. Then it would have 4, because let's say 4's timestamps precedes 5's. But 1, 3, and 2 have the same timestamp, so we'll circle it with this green. These 3 have the same timestamp. That means when we sorted through this list, because the list is not in order, it would have 1, then 3, then 2. And then the next slowest would be 4, and then the last would be 5. Red for that one. So the final order would be incorrect. It would be 1, 3. Whoa, no. See ya. Alright. Then 3, then 2, then 4. So this is not good. This is bad code. I knew there was an instance like this. Create that scenario. So then, what about if we just sorted by counter? If we only sorted by counter instead of sorting by timestamp, we would be good. We don't even have to worry about sorting by, we don't have to worry about sorting based on both of them. We could just sort based upon the timestamp, the count alone. So let's erase this TS. And this is now going to be sort by counter, or CO. So the values in this list are going to be received in this order. We'll have 1, 3, 5, 2, and then 4. Yeah, so there we go. 1, 3, 5, 2, 4. And then when we sort by counter, because let's just say the number represents the counter is always going to change. So when we sort by the counter, it will work every single time, because the counter will never be the same. And it should have the correct counter. We did that demonstration yesterday. So it would have 1, 2, 3, 4, 5, which, as we know, means smiley face. That means it will work exactly as we want. Big smiley face, okay? Now, so we need to change this. sort via counter. Since server-side receive can't just use counter, and that's not true. Server-side receive can use the counter, so that was just, I was wrong. Hopefully I'm not wrong this time. Sorts via counter. But we have to make this sort. We have to make this sort based on the sorts via timestamp, but then this one is going to be sorts via counter. So we're going to comment this out. Say replacing this code with above line, keeping until 100% sure replacement is valid. Alright, so we then would have to do a similar operation. But that sorts by the counter. Okay. And how do we do that? Well, that's easy. It would just change the tube index because this is going to be timestamp, dir string, adder name, data. Let's go this again. Timestamp, dir string, adder name, data, C1 apply counter, and then C2. So we want to change it to tube 4. So this is going to sort based on tube 4. Oh, I see. Oh, I see. I see. We have to add an if. We have to say if current client ID is equal to 1, we would sort based on the sort based on this. But if we had the client equal to 2, we would sort based on the 5 index. So yeah, we have current client ID is 1, received tupless sort. This is going to be based off of the C1 counter, and then this one is going to do it by the C2 counter. Yeah, I think this is right. At 4 tube in current client. Let's see. It's iterating through the receive change attribute list. It's iterating through, and then it's gonna append, and then we're gonna sort after the for loop. So that's correct. That's the proper order, I'm pretty sure. Yeah. So we have ID equals 1. Just make sure that's at the right indentation level. We then sort the receive cal tupless based on the key at index 4, which is the C1 counter. Just to triple check that, we have timestamp, dir string, adder name, data, C1 apply counter is index 4, so C2 is going to be index 5. So that's correct. this is correct, and then we have this is correct as well. So you've got to do the sort key to index 5. Yeah. Placing this code with above. Alright, with above section. So we need to div this out. Fucking back is hurting me, man. There it goes. I really hate this pain medicine though. It's pretty bad. I really don't like taking my pain medicine. It just kind of makes me spaced out a little bit. Okay, so I think, I don't know, I could go a little bit more. I think I'll actually stop though. I have something I need to take care of. So, unfortunately, we're just gonna have done this little hour and what, 15 minutes today, and I'll do more tomorrow, hopefully. So yeah, I think that was good. Let me put where we stopped at. So we need to go back to C1. Well, I'll say that we stopped right here. It was a little bit convoluted the way that we did that process because we got sidetracked, but it was a necessary sidetrack. Say need to, how do we do this? We'll say need to finish project searched for C1 to C1 apply counter. Also need to finish this section logic in accordance with above changes. Also need to finish this section's logic in accordance with above changes. Yeah, so need to finish project search for C1 to C1 apply counter. Finish this section's logic in accordance with the above changes. That's true. What we also need to replace the expect counter logic and adders in the same way as the apply counters. Yeah, that's good enough. Okay, so this was line 572. So we're gonna go to devlog, go to the end. Oop, wrong file. Devlog. Put stopped at line number 572 in client. Alright. So we went to 616, which is actually going to be a little bit further to stage and commit our changes. To 618. So 502 to 618 is an hour and 15 minutes, 1.25 hours. Alright. Now we're gonna go over here. We're gonna do git, make sure we're at the root of our project directory, which we are. Then we're gonna do git branch to check our branch. Git add. Why didn't that show anything? What happened there? Git add dot. Why is this didn't show anything? That's weird. That's not supposed to happen like that. Git commit dash m double quotes. Double quotes. We create a commit for files changed. 97 insertions. I don't know. I thought it usually gave me those LF warnings when I did git add dot. Pretty sure it did. I don't know why it didn't give me those warnings for whatever reason. Anyway, hopefully that doesn't mean anything was amiss. So we did 4 files changed, 97 insertions, 48 deletions. So then we're going to do git push Canasta secondary. Alright. So now we push to our remote repo. So we're done here. I don't know, my computer's acting funny, I think. Things are still really old with it. It's like got a dinosaur motherboard and CPU. But it is an updated one. I mean, it's one of the best dinosaurs out there. Back in its day, it was the GOAT. That was like 10 years ago. So 10.8. Let's go back. And now we can rename this to the 8th, which reflects today's date. There we go. So now we have a more recent backup. Alright guys, well, I'll